today on how it's made dream cars. Lamborghini was founded in 1963 by Ferruccio Lamborghini in Sant'Agata Bolognese, Italy. Lamborghini was already a wealthy man manufacturing tractors, but wanted to build a sports car to compete with Ferrari, and his subsequent creations can be seen at the company museum. The first car given the Lamborghini nameplate was the 350 GT, produced in 1964. Just 120 were made, and it had a 3.5-litre V12 engine. Lamborghini redefined the notion of the supercar with the Miura, which they produced between 1966 and 69, when the new 370 horsepower Miura S was launched. The ever-popular Countach from the mid-70s created Lamborghini's legend. A signature design with a wedge-shaped body and scissor doors left enthusiasts and onlookers speechless. Lamborghini's newest supercar is the Aventador. Its monocoque structure is made from carbon fiber, to which aluminium frames are added. The lightweight engineering, four-wheel drive and remarkable handling means the 6.5-litre V12 engine can accelerate this car from 0 to 100 kilometers per hour in just 2.9 seconds and can reach a top speed of 350 kilometers per hour. This sports car's monocoque is made from carbon fiber. To build up some of the parts and avoid unnecessary use of the material, some sections are built around epoxy foam. This means the car is extremely robust and incredibly light. In a climate-controlled, dust-free room, a large sheet of resin-impregnated carbon fiber is pulled onto a vacuum-based cutting table. Next, a protective plastic film is applied on top and is vacuum sealed through the pores of the carbon fiber sheet. A computer-controlled cutting machine then cuts out the patterns to maximize the use of the material. It's called a flatbed cutting machine and uses an air suction system under the table's surface to completely flatten the carbon fiber sheet. During cutting, the ultrasonic knife uses a pressure wheel to hold down the fabric to ensure the patterns are cut with clean edges. After removing the plastic film, the carbon fiber pieces are separated and inspected. Any excess is trimmed off. The pre-cut pieces are then grouped together according to their specific position within the final construction of the car. Next, the carbon fiber pieces are fitted into various molds of the monocoque. Each piece has a self-adhesive backing and must be fitted precisely into the mold. The material's patterns have to match and crisscross in order to construct the required thickness and strength. Once the protective film is removed from the carbon fiber piece, it's fixed into position using a squeegee that sweeps away any air pockets. The edges of the pieces are overlapped at the intersections of the mold. This means that the carbon fiber pieces will eventually become one complete element of the car. The monocoque is composed of a range of small to very large sections. Some are easily applied, whereas others require a lot of work to fit them. Next, a protective plastic cover is placed over the mold, followed by a white cloth. Then a thick plastic vacuum bag is fitted over the whole mold, and vacuum hoses are connected. The air is then removed, resulting in gravitational pressure forcing the layers of carbon fiber to shape to the mold. The mold then cures in an autoclave at a temperature of 135 degrees Celsius. During this process, the carbon fiber releases the impregnated resin into all areas of the fabric. The vacuum bag and protective white cloth are removed to reveal the solidified carbon fiber part of the monocoque. The mold is then disassembled to allow for the easy removal of the part, in this case, the roof section. It's then transferred onto a work cart, where any excess resin is removed. The monocoque also uses lightweight epoxy foam. First, the protective wrapping sheet is removed from a pre-cut piece of carbon fibre. The self-adhesive backing is then heated with a blow dryer. The fibre piece is placed onto the epoxy foam and then scraped to remove any wrinkles. Once in place, the green protective wrapping is removed, revealing the carbon fibre. The rest of the carbon fibre is then pressed into position, using the squeegee to remove any air bubbles. The self-adhesive backing is reheated before the last section is fitted. The biggest advantage of the epoxy foam is that the lightweight material can be shaped and fitted into almost any form. This epoxy foam component will be placed in a strategic position of the carbon fibre monocoque to increase its stiffness and rigidity. The car's foam components will act as spacers between the composite layers, whilst also dampening any noise and vibrations. The next stage of the process is to begin the manual assembly of the tub and roof elements of the monocoque for the Lamborghini Aventador. It's such a labour-intensive process to produce the Aventador's lightweight chassis made of a carbon fibre monocoque and aluminium subframes that 146 carbon fibre specialists take 24 hours to build 4 monocoques. In the late 1980s, the company experimented with a chassis and body made of lightweight composite materials, which yielded valuable design information for future cars. The look of any car is essential, but this car styling is revolutionary. The designers constantly sketched new renderings that were extreme. But key were aerodynamics that played a large role in the car's eventual design. To complete the chassis, first the rear subframe is positioned against the monocoque. Then the two parts are bolted together. Further chassis parts are positioned and then fastened. Once the chassis is complete, an air hoist manoeuvres the frame to another workstation, where the car's aluminium body panels will be fitted. Here, a machine brings the rear body shell panels and positions them on the chassis frame. Once the body panel has been placed, the unit moves away so the installation can continue. The placement of the panels are then checked to ensure that they're properly aligned with the front panels. Then a holding brace is slid into position so that the bolts can be fitted. Once all the body parts are fitted, such as the bonnet, doors and wings, as well as the carbon fibre engine cover, it begins to look more like a supercar. Next, the complete frame and body is sent off to an off-site paint shop to receive its many coats of paint. In the paint shop, the first stage is the removal of any defects and the application of a coat of primer. Then in the second phase, the primer is sanded in preparation for the base coat. There are 13 colours available, and painting this car is a lengthy and extensive process. All 27 parts of the car's body are manually spray painted, using a total of 8 litres of paint and taking 200 hours. More hours spent than on any other car in Lamborghini's history. Once the paint is completely dry, the surface is repeatedly buffed, removing any imperfections and leaving a high glossy finish. almost 3 days are spent on polishing the car for the perfect shine. Before the body leaves the paint shop, it sits in the ZP5 quality control checkpoint, a specialised light tunnel where it undergoes intense scrutiny for 2 hours by a certified auditor. Here, the quality of the work is checked and any imperfections are marked. If there are any flaws found, the body is sent back for either repolishing or repainting. The coated body of a Lamborghini Aventador is not allowed to leave the shop without this man's seal of approval. Today on How It's Made Dream Cars is the Lamborghini Aventador, which, like its predecessors, is powered by a V12 engine. But this one is a bit different, as it only takes 50 milliseconds to change gear. The cooling system of a car's engine requires a thermostat to regulate its temperature. In the case of the Aventador, it has 2 thermostats. These are positioned in the cylinder block, then the covers are screwed into place. Next, O-rings are fitted into the groove of each cylinder liner. These rings act as a seal, preventing any unwanted loss of vital fluids. The liners are positioned into the cylinder block and malleted into place using a protective cap. The cylinder block is then rotated so that the crankshaft can be installed, which is positioned into the crankshaft bearing cap casing. The crankshaft transmits the car's torque from the pistons and connecting rods to the drive shafts, using various gears, belts and chains. Once all the elements are installed, the cover known as the crankcase is fitted. Once the crankcase is fitted, the crankshaft is cranked to ensure that all the parts operate perfectly. Next, the cylinder block is rotated into another position, ready to install the pistons and connecting rods into each cylinder liner. These are tapped into place. The ends of the piston rods are aligned with the crankshaft. When every piston is in position, they're bolted to the crankshaft. The crankshaft is again rotated to check that the pistons move correctly. Using a special double-headed screwdriver, the cylinder head cover is then bolted into place. Before fitting the engine to the chassis, if there are any repairs needed to the car's monocoque, then skilled flying doctors arrive to complete the job. A large coin is used to knock on the monocoque to detect the acoustic differences in the structure's solidity and determine which areas require attention. Those areas that are damaged are marked with a white marker, with details of any required cut lines and the positions of the replacement patches. Severe damage is repaired with patches of resin-impregnated layers of carbon fibre. After removing a damaged area, a backing plate is inserted into the hole. The backing plate is manoeuvred into position. This plate is larger than the hole and has paste adhesive around its edge. Next, 2 rivets are inserted into the monocoque, which temporarily hold the backplate in place. Once the backing plate is set, the rivets are removed and the patching work continues. A larger double-sided piece of adhesive is then placed over the damaged area. Using a squeegee, the layer is smoothed, removing any air bubbles or creases. Then a pre-impregnated carbon fibre layer is stuck onto the piece of adhesive. Finally, a larger pre-impregnated carbon fibre layer is stuck on, which covers the entire damaged area. Again, the material is squeegeed to remove any wrinkles and air pockets. The patch section is then vacuum sealed, and a heated blanket cures the resin in the many layers. And that's how the Flying Doctors fix damage to the monocoque of a Lamborghini Aventador. The Lamborghini Aventador is not only extremely fast, but it's also very safe. The carbon fibre monocoque has high torsional rigidity, producing great handling, but it's also incredibly strong and robust. The assembly shop consists of 11 workstations. At one station, in an automated frame, the car is rotated vertically so that thermal acoustic insulation blankets can be installed. These come complete with self-adhesive backing. Next, the coolant hoses are mounted onto the chassis using clips that are already fitted to the undercarriage. The car is then rotated into its natural position once both hoses are set and the pipe secured. Next, the transfer case, which is part of a four-wheel drive system, is connected to the transmission, as well as the front and rear axles. The transfer case receives power from the transmission and sends it to both axles. It's mounted using a lifting device and then manually bolted in place. For authenticity and identity, each frame is engraved with the model type and year of production. The future owner can even have their name etched in too. Next, the dashboard is installed. The colour of the dashboard can be personalised, with options such as single colour or two-tone leather and stitching. The rear of this supercar is the most complex part of the vehicle. In another section of the assembly shop, the V12 engine, the gearbox and other engine components are manoeuvred over and into the rear midsection of the body frame. At this stage, all the specified cable and piping is fitted. Another important aspect of the car is its suspension system. In the Aventador, it's unusual, as the pushrod suspension of springs and shock absorbers are fitted transversely inside the body. Once the engine has been installed, the rear wing is fitted. This is a vital part of the car's performance and opens during mid to high speeds. It creates downforce, pushing the car closer to the road for better grip. A measuring gauge is used to ensure it's accurately fitted. The rear wing is then tested to check its 3 preset positions. Next, the rear body panel is installed. After which, the leather bucket seats are fitted into the cockpit. These too can be personalised. Then come the famed and iconic scissor doors. The suspension uses a push rod system with aluminium double wishbone control arms. A bell crank actuates the internal vertically integrated spring and damper unit. This allows the wheels to be glued to the road when cornering at high speed. Also, the carbon fibre ceramic brake discs give the Aventador incredible stopping power. Now complete with its optional black alloys, the car leaves the assembly shop for its extensive test drives. Like a futuristic aircraft, the scissor doors can open by remote control using the car's keyless entry system. And when you actually get inside, the aircraft appearance continues, with its central controls appearing to be inspired by a fighter jet. Even down to the cover for the starter button. Named after one of the most courageous bulls in Spanish bullfighting history, the Aventador is a beast powered by the Lamborghini V12 engine. Both its innovative design and styling are incredibly striking, achieving Lamborghini's wish to design a car to compete with Ferrari. A car that's a far cry from the tractors that began his automotive career.